We're checking out this atomic structure worksheet. Now, in one tab, I have open the worksheet, but in another tab, I have the periodic table of elements open. We need both. So let's do this example, and then I'll do neon also. I'll do oxygen, and then I'll do neon. So for oxygen, the number, ooh, they wrote it a little differently. Okay. So let's check out the element oxygen. Let's find it. Okay. It happens to be right here. This number 8 is the atomic number, but it's also the number of protons. So that 8, let's fill that in. And that's never going to change. That number is the same for all elements. It represents their protons and it represents their atomic number. So it's protons slash atomic number. You can use that term interchangeably. It means the same exact thing to a scientist. So you could say proton or you can say atomic number. Everyone will know you're talking about the same thing. So for this one, oxygen has 8 protons. It has 8. The atomic number is also 8. 8 happens to be located right here at the bottom. Now let's talk about neon. I know I'm jumping a little bit, but neon. Its atomic number is 10. That means it has 10 protons. The O, that represents oxygen. Let's say you have a letter that you're not sure how to find, you don't know what the symbol is. Like sometimes I mix up MG and MN. The names are super similar. If I want to know the name of MN, if I scroll down to the next page, MN was 25. That's manganese. The name's right here. Whereas if I was looking at 12, which is Mg, its name is magnesium. So you can find the names here on this next page, table S, if you need. Mm. So that's oxygen. It's the symbol. That's the chemical symbol. So I could write that in. Oh, let's go with green. Now, oxygen is the name of the chemical, the atom. And this last number is the atomic mass. This idea is slightly tricky. This atomic mass number. We're not, I wanted to change it, whatever. The atomic mass, we're not talking about one exact atom. This is just an average mass of all the oxygens on Earth. So this is just an average. Kind of like if I picked up a random oxygen atom, chances are it's gonna have a mass of 16. I know that because this number is basically 16. But someone collected all the oxygens in the world and found out their average mass and found out the average mass was 15.999. So this number doesn't talk about one atom. It talks about every single atom's mass and they added it all together and then they divided by the number of atoms and said, oh, the average mass of an oxygen is 15.99. This is just an average. So this is an average. Um, how do you figure out the number of neutrons? This you can't do for any of these. So just like FYI, you can't do N, you can't do N, you can't do N. You need the mass number. The mass number will equal your protons plus your neutrons. Make that a different color. Okay. So in order to find out your neutrons, you would need the mass number. We don't have that on this table at all. Like this is the atomic mass, that's an average. The mass number is talking about one exact atom. This is talking about all the atoms. So you can't do it for any of these because they don't tell you the mass number. They just give you an average of all of them. So you can't solve for any of these n's. Since all these are atoms, their protons and electrons will be the same number. So I was here. So because they're atoms, their protons and electrons are equal. So I'll put that note right here. So all atoms have the same number of protons and electrons. Say all atoms P equals E. That's if it's an atom. Doesn't have to be, but if it is an atom. Okay, hopefully that leads you in the right direction. Definitely email me back if you have more questions. I'll make another video if you need.